Hello, welcome to Agronomy Day. My name is Joe Spencer. I'm an entomologist. I've been here at the University of Illinois now for 25 years. I've been studying corn rootworm beetles throughout that period. Today, I'm going to update some information on rootworm beetles in Illinois, and I'm going to talk about the status of Bt resistance in Illinois corn rootworm populations. And to start, let me review a couple of basic points or facts. Corn rootworm beetles, that is northern corn rootworms and western corn rootworms, are our number one corn pests. In the last 20 years, we've used Bt corn hybrids to manage these insects, and they have provided great value. However, Bt resistance, which has been growing since early in the 2010s, is now an obstacle to managing corn rootworm beetles, both northerns and westerns. One of the reasons behind the rise in resistance in Illinois and across the Corn Belt is really overuse of Bt hybrids when there were populations that didn't actually warrant treatment for an economic population. Looking forward, future products that may be coming down the pike are going to be more durable if we only apply them when there's a justified reason, when we have a population of rootworms that are at an economic level. And we also need to think about using other tactics. I like to say Bt corn hybrids are a great tool, but it shouldn't be the only tool that you use. And also going forward, resistance to all the current Bt hybrids, which is the problem that we're facing, or to all the Bt traits, is going to increase the pressure on any new Bt traits or other types of modes of action that come onto the market. So we need to be very cautious about how we use these products. All right, let me show you some data on resistance now. This is a graph showing the survival of corn rootworm larvae that were tested in bioassays that I ran this year. I've been doing bioassays since 2013, and in these bioassays I will take corn hybrids expressing different Bt toxins, grow them along with a non-Bt hybrid within the same genetic family, and then I inoculate western corn rootworm larvae and northern corn rootworm larvae onto these plants, 10 larvae per plant, and I give them 17 days to do their development, and after that point we collect the roots from these plants and use some tools to extract the larvae. Then we can count and measure those larvae and understand the survival of the western and northern corn rootworm larvae on Bt and non-Bt corn hybrids. So these are data for populations that I collected last year. We looked at 3 populations of western corn rootworms. They're all from northern Illinois, from Kane, Stevenson, and Warren County. We also looked at 1 northern corn rootworm population from Kane County. In addition, I'm also showing some data from 2019 where we looked at a northern corn rootworm population in the adjacent county, DeKalb County. All right, so what did we find? Well, let me orient you a little bit to this graph. So the heights of the bars represent the proportion of larvae that survived the bioassay. So I put 10 larvae in each bioassay. So what you're seeing here is the proportion out of 10 larvae that survived. The heights, or excuse me, along the x-axis we have the Bt toxins that we evaluated. We looked at Cry3 BB1. We also looked at Cry3435 AB1. These are more commonly known as the yield guard rootworm trait and the Herculex rootworm trait. And then we also looked at larval survival when they were bioassayed on a pyramided hybrid that expressed both of these traits. In this case, Cry3435 and the Cry3 BB1 trait. The populations that we collected in the field are shown with black bars, and a population that's known to be susceptible to Bt is shown in these gray bars. So let's dig into these data a little bit, focusing on the western corn rootworms first of all. So if we're looking at western corn rootworms on the Cry3BB1 trait, we see when we compare the heights of these bars that the suspected resistant population here survives just as well on the BT hybrid as it does on the non-BT hybrid. And there was also no difference in their survival compared with the susceptible population on non-BT. This sort of pattern is indicative of a population with very high resistance to the trait in question. And in this case, we have high resistance to the Cry3BB1 traits in northern Illinois and generally around Illinois. If we look at the Cry3435 trait, we see a slightly different pattern, but it's similar in some ways. Looking at the suspected resistant populations, we find that they survive quite well on Cry3435. They survive at a rate that's much higher than the susceptible population, but their level of survival is not equivalent to their survival on a non-BT hybrid within the same genetic line. So this tells us that we have some resistance in this population, in fact quite a bit of resistance, but it's not yet equivalent to survival on non-BT. The Cry3435 trait is killing rootworms, it's just not killing all the rootworms. Then if we move on and we look at the pyramided hybrid, so this is the hybrid expressing two different modes of action against rootworms, we see a similar pattern. The larvae survive much better than the control populations on the BT hybrid, but their survival is a little bit less than the survival of the population on non-BT or the susceptible population on non-BT. Again, we see a pattern that's sort of similar, and this is to be expected because we know the Cry3 traits aren't providing much protection for this corn, and most of the value of the pyramided hybrid is coming from the presence of the Cry3435 trait. So while we have resistance to Cry3BB1, we have still getting some value from the 3435 trait. If we step down and look at the northern corn rootworms, we see a slightly different pattern, maybe more alarming. With the northern corn rootworm tested on the Cry3BB1, we find that the population survive just as well on BT as they survive on non-BT. So this is only the second year that we've tested northern corn rootworms. The only other population that we tested had a very similar pattern. They're quite resistant to the Cry3BB1 toxin. If we look at Cry3435, we see a bit more of a confused problem, and that is, statistically speaking, there's no difference in the survival amongst the survival proportions amongst larvae tested on all the different BT hybrids. We do see that the populations of the suspected resistant population survive just as well on BT and non-BT. And if we look at the comparison in the pyramided hybrid, we also find a pattern that's reminiscent. However, in this case, again, we have no difference in survival on the pyramid versus the non-BT genetic line that the pyramid is in. However, in this case, we did have significantly less survival amongst the susceptible population. This is a little bit alarming, and it's maybe not unexpected. Research out of the University of Nebraska has shown that laboratory populations of the northern corn rootworm are generally not very susceptible to the Cry3435 traits, especially in plant-based bioassays, which these are. Interestingly, if we go back and look at the data from 2019, I was only looking at the Cry3BB1 and the Cry3435. The pattern of larval survival is almost identical to what we found in 2019. So the information of the news here is that western corn rootworms are developing some fairly high levels of resistance to BT traits, and the northern corn rootworms look like they're also quite, they have little susceptibility to the traits present in the BT. All right, well, let's go on to one more topic here, and I'll ask the question, so what else can we learn about our populations by looking at these resistance patterns. And one of the things that we can do is take these patterns of survival of larvae on BT and non-BT and do a mathematical correction to let us see what portion of the survival of the population is really due to BT. So we call this correcting larval survival. And we can correct larval survival on BT corn for the background level of survival on non-BT corn to estimate the proportion of the larvae in the population that are killed due to the BT traits. And we do this by dividing the proportion of survival on BT corn by the proportion of survival on non-BT corn. And that gets us corrected survival. So this figure shows data that have been collected since 2013 on westerns and northern corn rootworm beetles. The height of the bars is equal to the proportion of larval survival that's been corrected. Along the x-axis is the year in which the populations were collected, and I've color-coded the bars based on the trait that we're looking at. So orange is for Cry3 traits, blue is the Cry34-35 trait, and the green is for pyramided hybrids. So what do we see with western corn rootworms? Well, one of the things that we note is that with respect to the orange, the Cry3BB1 trait, we've seen a rapid increase in the survival of larvae over time. And now, each year we have essentially equivalent survival on just BT, on Cry3BB1 and the non-BT hybrid. So the rootworm larvae are basically unaffected by Cry3 toxins now. If we look at the Cry34-35 trait, we see a different pattern. We had low levels of survival on those hybrids, corrected survival, but over time we're beginning to see, I believe, an increase in the survival of the larvae on Cry34-35. Populations in 2019 were surviving at about 51%. That being, what that means is over 50% of the western corn rootworm larvae on a Cry34-35 expressing plant are surviving that experience. I have populations from 2020 that I haven't quite finished the bioassays on. So far, the trend's looking like this number is going to hold or even go up for 2020 in Champaign County. If we look at the populations from northern Illinois that I just showed you on the previous panel, and we look at their corrected survival, we see that the western corn rootworm beetles have very high survival on the Cry3BB1 traits, meaning that BT toxin is not killing rootworm larvae well at all. And somewhat more alarming is when we look at corrected survival of the westerns on the Cry34-35 and the pyramided hybrids. There we have 70% survival of larvae on the pyramided hybrid. This isn't good news if you're trying to grow corn in northern Illinois, and it's really borne out by a lot of the concerns and various reports you may have seen on Twitter or on sort of the ag news services about rootworm problems in the northern part of the state. If we look at northern corn rootworms, we also see a rather alarming situation, and that is when we do corrected survival of those insects on the two individual traits or on the pyramided hybrid, we find very high survival, essentially no different from these insects surviving on the non-BT. So bottom line here, to summarize, rootworm resistance to all traits has increased over time. Northern corn rootworms in northern Illinois are also resistant to the BT traits, with the caveat that we know that these populations probably had reduced susceptibility to begin with. Pest monitoring and rotation of multiple tactics are really going to be needed to slow future resistance selection. We can't just plant BT over and over and over again. We have to manage the use of these products so that we only use them when they're needed and that we put them on the right acres. BT corn is a great tool, but it shouldn't be the only tool you use. Going forward, we really need to be conscious of the threat that resistance poses to the sustainable management of these insects. We've been lucky in Illinois not to have really high rootworm populations for several years. But if you look to the west in Iowa, Minnesota, Nebraska, they're suffering with very high rootworm populations this year. We need to think about incorporating crop rotation, use of soil insecticides when it's possible and we have low populations. We also need to be doing monitoring so we can make informed decisions and begin to think about other tactics, one of which is the use of entomopathogenic nematodes. So these are worms, tiny worms that can be put into the soil that feed on rootworm larvae. And there are a number of experiments going on around the Corn Belt where people are looking at the possibility of using nematodes to reduce rootworm pressure in fields. I'm part of a project here in Illinois that's going on in Nebraska as well as Iowa, where we're looking at innovative ways to try to manage rootworm beetles. Using entomopathogenic nematodes is one of those things that we'll be trying, and we're looking for growers who might be interested in helping us, who wouldn't mind having some nematodes put into their fields, and also gaining free access to some cover crops and allowing us to monitor rootworm beetles in an effort to try to understand how we might work together with rotation, nematodes, and Bt hybrids to manage rootworm beetles more effectively in the future. So with that, I close and I say thanks for your attention.